Good morning, mathematicians. I forgot my little stick thing that my microphone goes on, so you're gonna have worse audio today, probably. Slightly worse audio today. Wow! 595. We're so close to 6. That's crazy. That's crazy. Wild stuff. I kind of like seeing myself a couple seconds in the past. Looking at a younger man right now. Looking at a younger man. Interesting. The cover could be an error. Oh, the memories. Yeah, exactly. Yeah, I guess that makes sense, but wow. That would have been, I don't know, pretty funny. Or devastating, I don't know. Hello, Meadow. Good morning. Ah. Well played. Well played. Oh, quick questions. I never even thought to go to quick questions and career and education questions. We could probably find all sorts of good stuff there. This is an interesting question. Oh, hello, Tenacity. Hello, Tenacity. I've thought about this before, you know, like, well, I'm not the first person to think about this, but yeah, like modeling colors, you know, when you've got like RGB as a basis. But it's interesting. It's like, it's a basis, but you're almost looking at like a convex hull of these things, right? Because you've got your saturations from like 0 to 1, for example. So I guess really it would be like a cube, a color cube. Well, maybe I'll have to come back when there's more answers here. I definitely know I've seen other things out there that talk more formally about colors. Does geometry actually exist? What a question. No. Whenever I think about geometry, I always think about it as a tool for visualization, but not a rigorous method of proof. I see what they're saying. For example, we can think of Rn as an n-dimensional space, which works up to 3 dimensions, but after that we need purely algebraic, yeah. Yeah, I mean, that's true. It's absolutely true. Yeah, I mean, everything that we call like differential geometry and stuff, we're pushing symbols. The ratio of RGB cones varies from individual to individual. Interesting. Well, what do you mean by skeptical of color theory claims in general? I mean, those might that might vary from individual to individual, but you know, we still can predict what will happen if you. There's still a sense in which like RGB are kind of like a basis, or you know, you mix. If you do 50% red and 50% green, you know, we can ballpark what happens. I mean, definitely. I mean, regardless, 100%. There's like interesting mathematics to explore there. I'm sure. But that is interesting. I didn't know the cones vary from person to person. But that makes sense. I mean, now that you say it, most things are going to vary somewhat from person to person, right? Just physically. Yeah. You've been struggling a bit with setting goals in what you learn. Like, you can always go deeper into a subject and understand better, and you never know how to set your expectations. Got any tips for that? That's a good question. Yeah, that's a good question. How to set your goals. I mean, if there's a particular theorem or result you're trying to understand, you want to ask some recommendations. Yeah, please ask some recommendations. As in, there are even people who have a primary color for each cone in their eye. Sorry, I'm not sure I understand. We have 3 cones, right? Isn't it? I don't remember my basics of how human vision works. I thought we had 3 cones, and it was like one for each. But that's not a typical thing. Interesting. I'm gonna have to read up more on this. But yeah, so for setting goals. I mean, one thing is to get, I don't know, interested in a problem, right? Like an open problem, or try to understand something like that. Like, I've learned a bunch of things through that, through that desire to sort of, and not to say that I ever ended up solving those problems that motivated me at the end of the day. But I find for myself, when I learn the most is when I'm really like addicted to something, to some problem or some idea that I'm trying to work through, like doing some sort of calculation. And I mean, this is dangerous because when I get addicted to those things, I blow off the work I'm supposed to do. And instead I do the mathematics I want to do. And I really can't help myself sometimes doing it, which is bad, but... So, yeah, I don't know if that helps. I'm so flighty in my mathematical tastes, that yeah, it's a good point. Learning a specific theorem can be open-ended. But I'm very flighty in my taste, so I'm reading about different stuff all the time, sort of naturally. I maybe still need to work on the problem of sitting down and drilling down into one thing very specifically. Well, that's not... Sometimes that does happen, but that's when I just get, like, addicted to a problem. Okay... no, 7/8 of men have 3 cones. 1/8 have 2 cones. Oh. Half of women have 3 cones, and up to half have 4 cones. Wow. If you don't have cone clusters into groups and each cone is their own primary, that is fascinating. Huh. That makes so much sense. Well, not so much sense, but... Actually, I mean, the different number of cones is surprising. Like, I would expect maybe cone ratios or something. That is very believable to me. But just number of cones, that is interesting. Is there any, like... Is there any sort of, like, racial or geographical correlation with that? Like, I could imagine that maybe people living in a very, like, if you're living in the Arctic or something, probably, like, you probably need keen eyesight because there's, things like polar bears are going to eat you. But, people versus people living in a very colorful environment, I don't know, more like a jungle environment. I would imagine there's a lot of colors, and maybe one could imagine an adaptation. But actually, how long? What are even the human timescales for evolution? Are these differences in environment? Yeah, surely there's enough time to have made a difference in that sense. That was fascinating. Vamp Cardi is already a physics major and very close to taking a math major, but not at all good at a few of your analysis classes and left math major completely. Now trying to learn pure math again. That was great. That is great. I'm guessing you've got a follow-up question. Yeah. Do I have any book? Do I have any book recommendations or any resources for proofreading, analysis, and some of the undergraduate math for a self-learner like me? I've got a new series on how to write proofs, and another series where I roast other people's proofs. But no, more seriously, resources for proofreading analysis. The thing is, I can give you a lot of recommendations, but a lot of recommendations for things that I've never read, so it feels dishonest for me to recommend these things to you. Like, a lot of people talk about Polya's book, How to Prove It. It was what I named my series after that book. So that's probably a good resource. Lots of people seem to enjoy it, but it's a little dishonest. I never personally read the book. It just seems like a lot of people enjoyed that book. So that could be something to look into. If you're looking to do analysis, there's some like visual analysis, or there's some book that I don't know what it is. No, I'm not gonna get the right thing. There's some I don't know. There's a student in a class that I had. A student in a class I had some book. I think this is it. Wow, 220. That is insane. No, this isn't. Was it Bartle? I don't think it was Bartle. Anyways. Damn, sorry. I'm trying to find this book. A student in the class I had said they got this book off of Amazon, and it had some like nice visual introduction to analysis. So I don't know. That's what I would say. I don't know good proofwriting resources. Other than that, I would maybe. I mean, the other thing is you just got to read a lot of proofs, like in textbooks and stuff. It's like, how do you become a writer? You read a lot of novels, and then you sit down and you start writing. And you write a lot of crap that sucks at first. What are my advices for learning homotopy theory, like computing fundamental groups? But any time you try to move beyond that, you hit a brick wall. Yeah. Every resource you've seen is written in language of category theory, and you really don't like that. Well, then that's you're gonna have to get over that, or change your mind away from homotopy theory. That's literally all there is to it. I mean, if you want to go beyond just basic stuff about fundamental groups, you need category theory. It is indispensable to talk about homotopy theory. So, yeah, if you really don't like category theory, then I don't think homotopy theory is for you. Yeah. Sorry to say. Um, definitely share the issue of trying to learn 30 topics at once. Yeah. You bought a book called This Book Will Make You Sleep, and it's supposed to be a collection of boring things. One chapter is just a list full of algebra theorems. Oh. Oh, brutal. Brutal. Yeah, you give that book to a mathematician, they'll be up all night trying to prove those theorems. I literally never use the pigeonhole principle. But I don't work in combinatorics. I shouldn't say never, but like almost never. Yeah, that's just my work is very different from that. Let's see. Okay, we got lots of questions popping off here in chat. Homotopy theory is a great excuse to learn categorical language. Yeah, exactly. Why linear algebra? If it's analysis, at least it's understandable. Well, I don't know. Some students would feel differently. Some students would feel the opposite way. What did I specialize in grad school? Well, I am still in grad school, and I am specializing in, I guess, the local Langlands program. Yeah. I've got some videos on it. There's some previous streams where I chat about my research. Oh man, I got like stuff in my eye. Like analysis, but not PDEs. Solving PDEs is just the computing the kernel of a differential operator. Can you give me some advice on how I should proceed with reading research papers? Your area of research is modular forms. There are lots of novel words and terms in every paper. You get lost. Yeah. I mean, I certainly don't understand every word in the papers that I read. But you pick things up as you go, you know. So if there's if your supervisor assigns you a paper or something and is like, I want you to read this paper, you should, I mean, one thing you can do is, like, you should always sort of read the paper first at a high level, right? So you read the abstract, you know, you read the abstract, you read the introduction, and then maybe you kind of skim and you just read, like, you focus mostly on the like English words at the start of each section, and sort of like the key theorems, and just write down statements of the key theorems. That's sort of a place to go. And then, I mean, you don't have to keep a physical tally, although maybe that would help, but maybe a mental tally as you go of things like, you know, what are the key words that come up again and again, right? So if there are certain words that you keep seeing in and I guess after your first, or maybe in your first reading, also glance at the proofs, just see some sort of like, what are the words being said? Again, like a lot of the papers I actually use and cite and stuff, I don't understand most of the proofs in there. I mean, I probably could if I sat down and tried, but I don't always read them very carefully. I just sort of extract the information that I need and then I go. So yeah, obviously then the keywords, and then you'll have to spend some time, like, you know, backtracking to fill in the keywords, and do as much of that as yourself as you possibly can. But then, of course, you know, your supervisor should hopefully be able to help you at some point. But you know, you also got to come to the table and you know, bring a lot of work ahead of time to get there. Bartle is not $2.20 in your country. It's like $5. Yeah, well, to be fair, I was on Amazon, so like I remember I just saw, actually the other day, I'm not completely broke at the moment, so the other day. I've been meaning to buy my old backpack again because the current backpack I have sucks in comparison. But when I went to the store to get it, they didn't have a version of my old backpack again. Actually, what happened is just one buckle went, and I took it in for a return because I thought, oh, they would just get me a new backpack because this place has a good return policy. But then the lady just like took the backpack and was like, okay, you have this much credit, go get a bag. I was like, oh, that's how it works. And then I went and I looked at the bags, and then, yeah, they didn't have it. So I was like, I just grabbed this random one, but I was like, one day I'm going to get my backpack back because the last one was pretty good. And I did, so I ordered it. I don't remember why I was talking about this. I had a point. Oh, yeah, anyways, and I remember I was like, oh, I wonder, because I'm going hiking this weekend, and the thing I love about this backpack is I find it's great both for practical purposes, and it's also pretty well set up for hiking. I like to take it hiking. And anyways, on their website, it was, the bag was like, it's maybe like $100, a little over $100 or something. But then, I saw a version of it on Amazon for like $300. I'm like, it's the same bag. The book I was thinking of was not Visual Complex Analysis. It was not that. I know. It was good suggestion, but I was thinking of a different book. Wow, there's so many things in chat. I'm catching up slowly. You're finishing some of your group theory homework. Maybe you'll send you some of my proofs. Yeah, do it. Your professor said she prefers messy OG proofs over good proofs. The students copied from a book. Well, yeah. Obviously, don't copy a proof from a book. Yikes. But also write good proofs. Yeah, like Wikipedia for math, yeah. Why is category theory indispensable for homotopy theory? Well, that is a good question. I really like, there's this analogy here. So, you have two topological spaces. You have two continuous maps between them, and we can have a homotopy now between those maps. So we have a notion of objects, we have a notion of morphisms, and we have a notion of higher morphisms between those things. Where else do we have this exact same idea? Well, we have a category. We have functors between categories. And we have natural transformations between functors. This isn't just like a coincidence. I mean, this is I don't know, a sort of like fundamental insight. That there's some sort of like deep analogy going on here, that sort of thinking about higher categories is the same thing as thinking about topological spaces at the homotopy level. Moreover, there are, well, first off, the fundamental group has a somewhat debatably, unfortunate thing that you have to pick a base point. And yeah, if your space is path connected, all the fundamental groups will be isomorphic. But instead of having to make this sort of somewhat a natural choice, one can instead work with the fundamental groupoid, which is a sort of large collection that captures all of these groups all at once. And you then work with the fundamental groupoid. It's somehow a more natural thing. But to even begin talking about this, you need to you need to talk about categories, because a groupoid is first and foremost a category, subject to some special conditions. Also, for things like the connection between, say, vector bundles or principal bundles and homotopy theory, like there's a whole thing there. Like basically, it turns out that the space, the collection of continuous, like the study of all the possible principal G bundles you could put on a space X is equivalent to the homotopy classes of maps between X and some special space called BG, the classifying space. And ultimately, I mean, I suppose you can do things just on this level. Do we strictly need categories here? I mean, I think yes. I think still yes. But mind you, I think technically you don't need to use stacks to study this. Actually, I don't know. I should be careful. I should be careful what I say about that part of it. But then also, what else? Maybe I should see how much chat is popping off here. You get that homotopy is more than just homotopy groups. But if you want to learn how higher homotopy groups are computed, do you really need categories? Surely not. Yes, surely yes. Surely yes. Because the thing is like computing higher homotopy groups is very difficult. And so you need tricks. Like, what's this long sequence of homotopy groups? Like, I mean, right away. So here, right? Like, how do you compute higher homotopy groups? Well, you need some sort of theorems and stuff, right? Like you already know that you have theorems at your disposal, like Van Kampen's theorem, and maybe that it respects products, right? Tools like this, right? You build up some basic tools. By the way, Van Kampen can be written. Arguably, if you use this and the idea of colimits, arguably Van Kampen can be written even more generally if you use a category theoretic language. Products, you have all sorts of these different tools, covering space theory, right? You have these different tools that allow you to make computations, right? And so in the same way, you need tools, and higher homotopy groups are just they're very hard to compute. I mean, even pi 1 is very hard to compute, right? If you've taken a course, you've seen that it takes you like all semester, not all semester, but it takes you some time to just figure out what the fundamental group of the circle is. Not figure it out, but prove it, right? Okay, NLab has stated things more abstractly than is needed here, but for example, it says, if you have some particular kind of morphism between continuous map between topological spaces, then you can get a long exact sequence. So okay, we're talking about a long exact sequence. Already we're talking about like category theory at some level here. And but the advantage to this is now you're getting some relation between the higher homotopy groups of different spaces, and so you can use this as a tool to compute the fundamental group of some space you're interested in, or sorry, not the fundamental group, the higher homotopy groups in terms of homotopy groups of other things. So it is absolutely essential, like for every part of it. Um, can I use category theory to prove the direct limit of proof or group? I'm not sure what you mean. Because, I mean, one definition of the proof or group is to just define it as the limit over all n. So, or do you mean to prove that it's isomorphic to the product of all the p-adics? I mean, if that's what you mean, then it's you just have to recognize that this is a limit over all primes, and then you take another limit over all little n, and basically in between here, you're basically using the critical race theorem, which is what I call the Chinese remainder theorem. And then this is, I mean, depending on your definitions, this is just by definition the p-adics. And then this limit there's no maps between these things in the limit, so it literally is just the product. Pretty slick and quick. Actually, that reminds me, there's other things in chat, but I want to show you one of my favorite slick proofs. Ooh, I should make it into a short. It's a proof from Anton Dietmar's Automorphic Forms book. It's like one of my favorite proofs. Yeah, maybe that's the short I'll upload today. A big part of becoming good at math is getting used to listening to lectures you don't understand. Absolutely. And reading books you don't understand without zoning out. 100%. 100%. I will try to start learning. Do I think one can complete all of the compulsory undergrad stuff like group theory, etc. by the end of this year? Everywhere I ask, people just say you should give 4 years. You can definitely do it faster than a 4-year degree. 100% you can do it faster than the 4-year degree. It's spaced out in a very particular way. Now, the thing is, I do think, so let me tell you, I took a spring course once. And it was in like, it was like, calculus and RN, basically. And it was a little difficult, but I did fine. I got an A+. It was fine. But what I found was when I went to go, because it was all the information was so densely packed in the short amount of time, when I went to go take a course that depended on that information later on, I found I had forgotten essentially everything from that course. Because, and I had to like relearn a bunch of things, whereas a course that you take where, it's over like 3 months and you have more spaces in between class, like your brain is digesting this in the background. I was able to, like in other courses, I'm able to recall things sometimes even years later, because you just sort of sit in it longer. So that is something to be mindful of. But for you personally, I've no idea, without having an intimate knowledge of your background, your current strengths and weaknesses. I've no idea how long it would take you to get to some certain place. I do offer tutoring services. This might seem like a weird question. That's what we're here for. Weird questions. Please ask them. But I always obsess over this BS. You seem like an extremely intelligent person to me. Well, thank you. Looks can be deceiving. This is all a facade on the internet. You want to ask how many hours do I study per day on average? Yeah, I get this question a lot. I don't know. It's tough to say. When I'm obsessing on a problem, it's like I'm thinking about it every minute of every day. Someone's talking to me and blah, blah, blah. How are you? Blah, blah, blah. And I'm like, and then like in my head, the wheels are turning and I'm like not sleeping at night because I'm trying to like compute something in my head. But the computations never work out right in my sleep. And then there's other days where I do absolutely nothing at all because I'm like running around and doing groceries and thinking about other things. So it's very hard to say. Um, yeah. Do I? I wouldn't say I even put in a full like 8 hours of math on a typical day. Actually, that's not true. I mean, there's the things I'm supposed to be thinking about, right? But I mean, for myself personally, I'm like an obsessive. So I feel like I'm thinking about math like many hours of the day. Um, Gosh, yeah, I don't know. It's hard to say. It's really hard to say. I've never. Maybe I should. I get this question so often. Maybe I should somehow track it. But it would be difficult, because like I'll pause randomly to watch like a 5-minute video about like, oh, new research about what optimal protein timing, or oh, here's a video about, oh, we learned new things from this fossil, this missing link we found from 100,000 years ago, and then I like go back to thinking about math, or maybe while I'm watching this video, I'm doodling, but it doesn't have anything to do with what I'm supposed to do. So I don't know. BS. This is mathematics. Yeah, but that doesn't mean that it's not BS. It is all BS. It is all willy-nilly nonsense. Yeah. You want to research quaternionic schemes just for the simple reason that it's a cool name. That is a great motivation and is like half of why I'm in mathematics. Yeah. An analogy between categories and homotopy types exists on another level. The points correspond to objects and the paths to morphisms. Yes, that's true. Yes, and that is like my favorite. That is also one of my favorite things. Is just the basic idea of homotopy type theory. Wow, there's so much going on in chat. I'm so far behind. This is good though. This is the dream. This is the dream to have chat be so busy. Oh yeah, I forgot to even mention spectral sequences. Yeah, most tools for computing homotopy or cohomology depend on deeper categorical results like spectral sequences. Yeah, the results are just groups. They don't need categories, but the methods do. Yeah, exactly. It's just like good luck once you get past all the fundamental groups you compute in like a first course. Like good luck computing the others without these high level techniques. Yeah, clearly is the most dangerous word in mathematics. Avoid it at all costs in your own writing. I try to avoid things like this. Clearly, obviously, where I will go, I will sometimes say by a straightforward computation. But as a general rule, avoid this at all costs. Or when crucial steps are skipped in a paper. Yeah, I mean, yeah, life's tough. I don't know what else to say. Makes you feel small too, like they thought it was easy. They probably did. They probably did think it was easy. Yeah, life is hard though. I don't know what else to say. Yeah. I mean, when you're really stuck on those things, that's when you consult your friends and colleagues and supervisors and the internet and Stack Exchange. And then sometimes you'll probably get a response that, it'll be like really simple, like 2 lines, and you'll feel like a total idiot for not having thought of it. But you just got to get used to feeling like that because that's math. That's math, baby. Oh, Z sub P infinity. Adjoining all the Pth roots? Well, I think that's maybe on the lines of the short I'm going to release. So stay tuned for the short. Stay tuned for hopefully today's short. Hopefully I'll have time to upload a short today. Due to your poor math background, you got into group theory, a lot more convenient than analysis. Yeah, it's interesting. Yeah, there's so many people here, strong opinions about analysis versus algebra. What's easier? What's better? K-theory in chat. Any recommendations on orientability of manifolds? I don't have recommendations. Enough to understand how to get degree 2, mod 2 to the Brauer degree or something. Haven't taken a course on manifolds yet. Well, I mean, you got to learn some basic manifolds first. That's where you got to start. Wow, I'm so behind. This is great. This is the dream. So yeah, start from orientability of vector bundles, then look at manifolds. Yeah. My proofs review made you re-review your results draft paper 2,345 times. Awesome. That's the perfect number to review things, by the way. I'm glad the advice helped. Yeah, subconscious does keep working on math problems. Do maybe 2 hours a day on math? Wow. I couldn't only do 2 hours a day. If you paid me money, I couldn't only do 2 hours a day. I'm obsessed. I'm not saying this is a good thing. This isn't the brag. This is an admission of guilt. Would you say it's worth it to learn something like lean for reasons other than just I can formalize my proofs? Yeah, I mean, I think lean is awesome. I'm not sure I agree with Elemental Tango's comment that it'll allow you to read math others do faster without misunderstanding. I'm not sure I agree with that, but yeah, I think, I mean, in my dream future, we'll all be writing proofs in a proof assistant, and it will be as easy as just writing things up in LaTeX. That is the future that I dream of, and I think it's one that we should work towards. I think there's just so many reasons why. Like, if we imagine that we do get a user-friendly enough interface to make this feasible, it's just we have extra security in our proofs, at more confidence in our proofs. Why wouldn't you want that? I think it will make advantages to things like having like easily searchable libraries. There's so many out. So someone was just asking about, what do you do when there's a clearly in the paper or like a straightforward computation? Well, what you can do is we want to think of both what's the compromise that makes the audience and the author happy. Well, the author, if it really truly is just a straightforward computation, the author can normally just apply some tactic like rewrite or simple or something, and that tactic will just immediately carry out these trivial computations and move forward. And then if the audience wants to unpack those computations to actually understand how it gets done, they can then unpack that tactic and see what the thing did. And so it's great because like there's no hiding behind clearlies. But also it definitely is true that there are straightforward computations that are not worth your time to do. You can do it, and yet still those people who want to know those details can know those details. And I think there's already places where proof assistants, like I think as time goes on, there's be more and more applications of them. I mean, the sort of the project I'm working on for this program I'm participating in is part of a company, a sort of a startup branched off from a cancer research company that's looking at proof assistance. Yeah, but also it's just fun. Yeah. A moment's thought will show. Yeah, brutal. Learning proof assistant can really help thinking more structurally about ordinary proofs. Yes, I agree with that too. For next semester, you really want to take analysis, topology, group theory, and advanced linear algebra, but you obviously can't take all of them at once. Why not? Go hardcore. Go beast mode. Go beast mode on your math courses. Yeah, have you ever just considered engaging beast mode? That's the obvious solution. Well, if you want to specialize in analysis, then analysis. I mean, that's number one. Advanced linear algebra is going to be helpful. You should just know that. I would say take analysis, take advanced linear algebra. I mean, group theory is at the bottom of that list. Let's be real. And topology. So if you think you can take 3 courses, just don't take the group theory then. I should really show the power of spectral sequences in some shorts or lectures. You're right, I should, but here's an admission. I've never actually computed anything with a spectral sequence. I have used results that depend on spectral sequence results. Hello, Messi. But that's that. Oh yeah. So someone asked about another motivation. You know, it's a good motivation to stay in one topic and learn something. Start a YouTube channel and try and do a series on stuff. Yes, Vamp Cardi. Proof Assistant is exactly what Terrence Tao was recently using on his YouTube channel. I have a video. Called Hot Boy Summer, where I talk about both the foundations of homotopy type theory, and I go through some examples of proving stuff in a Proof Assistant. But yeah, check out Terry Tao's video. There's tons of great videos. Also, I'm forever plugging the natural number game. So this is a great place to get started. There are, you got the natural number game, set theory game, and lean logic game. You can just go right here right away. You don't need to install anything, and it gives you instructions. And it gives you instructions, and you can just start proving things in here. Terry Tao has been big on proof assistants lately. Not sure what caused him to take an interest in them, because they're incredible and they're the future of math. And since Terry Tao's a genius, it's obvious to him that that's true. And mathematical education, yes. I think so I see a lot of students struggling in discrete math. Sometimes they get lost in where they are in the proof and what order to do things. And I really think that proof assistants can be helpful in having them keep track of those steps and know when to be able to apply what where. How is group theory on the bottom of that list? Well, the person said that they're interested in analysis. And I mean, of course, groups come up in analysis. You do, like, especially if you're doing functional analysis or something, but like, in terms of like ranking out of the options that they gave, in terms of ranking what's going to be the most important for them, yeah. Yeah, no worries. I've always wanted to make some videos, but no clue on what. Also doubt you'd get much views. I mean, hey, I remember getting, like, a couple years ago, 2020 or something, like, I made my first video on some, like, basic number theory, like, how to divide stuff. Oh, sorry, Paul Maurice, I missed that question before. You asked about Gromov-Witten invariants. No, I don't know anything about them. But yeah, just make videos on random stuff. Like I just made like, oh, here's an introduction to modular arithmetic. And my videos sucked. And I got like 10 views on my first video, like in a couple days. And I was so excited. Because I was like, wow, people are watching this. Like some people have clicked on this video. I'm going to keep making more. So, you know, and now look at me. I just, you know, like what are these videos? What the hell is office hours? It's just me like running my mouth about dumb crap, you know? And look how many people tune in. Skeptical about proof assistance still. You're gonna get banned from chat. You learned a lot of homotopy type theory, even coded your own dependent type checkers. Amazing. Okay, well, okay, your opinion counts. You won't get banned now. It's a fascinating theoretical area, but the actual workflow is not nearly there yet. Yeah, I mean, I agree. I don't think it's gonna take over the world tomorrow. But long term, I mean, I don't know. I feel like it's in the same vein of people like doubting people doubting the stuff that like AI will be able to do in the future. I mean, at the same time, like people who are like, oh, AI is going to do this and that. Also, you know, be skeptical of the people who are making like definitive declarations about what it will do for us in the future. But it's also like people like, oh, no, it will never be able to do this and that. I'm like, okay, do you remember like only 2 years ago when people were making fun of like, you know, the Bud Light commercial it came up with that was just, you know, insane, or like the Will Smith spaghetti video. And then, you know, so first off, like what, 4 or 5 years ago, that it wasn't even conceivable. Okay, maybe people who are working on this were conceiving it, but like the general public had no idea of this. You know, there like AI was basically just like Grammarly, right? And you know, people weren't even thinking about the fact that you could just tell the computer to make a video of something, and it would be able to do it. And then, you know, 2 years after that, we had like Will Smith spaghetti video level AI, and we were all making fun of it, and it was funny. But like that already was an impressive thing. And then like another 2 years later, we have like, you know, the stuff that we have now, the you know, Ghibli-fying everything, and it's like, it's incredible. It's absolutely incredible, and how quickly we forget the leaps and bounds that have been made. And to say, oh, you know, to make definitive statements about either what it can or can't do 20 years from now, I mean, I don't know. Have you guys seen Equational Theories Project by Tao? I haven't, but I'm about to log off because my coffee's almost done. I gotta get proven. Doing a video series would be nice to follow through with something. AI image generation was absolutely horrendous just looking about 4 or 5 years ago. Yeah, and look at the changes. The annoying part is the AI bubble is not in the technological advancement; it's in the social perception of it. Yeah, that's true. One could say a similar thing about proof assistance, possibly. Well, there are technological challenges as well, but following up on the suggestion of doing videos, do I agree that one of the best ways of learning maths is teaching it? Absolutely. Start your own YouTube channel, and start teaching people math. I mean, I didn't really learn Galois theory until I taught the course in fall of 2023. Of course, I had done it before. You know, I wouldn't have been allowed to teach it otherwise. But, you know, I didn't feel like I truly understood it until I taught it. Even though the answer would be a trivial yes. There you go. Ask it anyways. Yeah. I think AI can do math much better than the best mathematicians. Well, currently, no. That is currently a false statement. The problem lies in the tokenization and how to feed it math statements to train. Well, there's a lot of things to discuss there, but we'll leave it for tomorrow. Because I need to go prove some theorems, and you need to go prove some theorems. I mean, I don't know what time it is where you are, but it's 8:38 where I am, and you gotta go prove stuff. You gotta go prove stuff. Look, how many hours have you been awake? You haven't proved enough. Change that now.